equivalent is 24 ohms. So if I start reducing this, I now have a 24 ohm resistor here. And I still have 60, 60, 45. Now I'm going to get the equivalent for these. So 1 over 60 plus 1 over 60 plus 1 over 45 is equal to 1 over R equivalent. Solving for R equivalent, I get R equivalent to be 18 ohms. So I can simplify this down now into a 24 ohm in series with an 18 ohm. And they're in parallel with a 21 ohm. So 18 plus 24, I can replace these guys with a single 42 ohm resistor, which is now in parallel with a 21 ohm resistor. Okay? So R equivalent for these two, to finally get down to one resistor, would be 1 over 42 plus 1 divided by 21, inverse of that. R equivalent is 14 ohms. So all of those resistors that I started out with gave me an equivalent resistance of 14 ohms. Okay? And I wanted to do that problem so you saw one where you had to go through multiple steps. All right. Now, let's talk about an ammeter. An ammeter. An ammeter is a device used to measure the current and has a resistance of almost 0. And it's put in series with the component that I'm trying to determine the current through. Okay? So ammeters are always put in series. A voltmeter measures the electrical potential between 2 points. And if we want to measure the electrical potential across a certain component, we always install the voltmeter parallel. And it has a high resistance, so no current really goes through the voltmeter. Okay, so ammeters are put in series, they're measured current. A voltmeter is put in parallel, it measures electrical potential. Now, real batteries have internal resistance. And because of that internal resistance, the electrical potential of the battery is always a little bit less than the EMF possible from the chemical reaction. So if you short circuit a battery, okay, you can say that the current when you short circuit is equal to the EMF of the battery divided by R. We're not going to worry about that. Now, let's think about designing and analyzing circuits. You don't do as much of this as you used to, but you still need to be familiar with it. And when we're analyzing a circuit, what we're trying to do is not only figure out the potential drop across different components of the circuit, but what the current through different loops of the circuit will be. Okay? You're going to use the loop rule, the junction rule, and Ohm's law. Now, there's several ways to go about doing this. Okay? But as you're doing this, and you're going to be creating systems of equations, you always want to remember that when you make a loop through a circuit, to have a new equation, you're going to have to include a new component. Okay? And that we can apply the junction rule and Ohm's law. Now we're going to look at problem 59 and problem 60. Okay? So let's look at problem 59. Now, problem 59 says, for the circuit shown, okay, find the current through and the potential difference across each resistor. Place your results in the table for ease of reading. So let's look at this circuit. We have a 24-volt battery, and then we have a 2 ohm resistor, a 4 ohm resistor, a 6 and 12 ohm resistor, and an 8 ohm resistor. Now, I have a kind of pattern that I follow when I'm solving these that I picked up years ago. This is not the only way to solve it. There probably is many ways, there are probably at least 4 or 5 different ways to solve this problem. So let's kind of look at it. Okay, so we start out here. And we've got this 24-volt battery. We've got a 2 ohm resistor. We got a 4 ohm resistor that splits out. We got a 6 ohm resistor. A 12 ohm resistor. And then out here, we've got an 8 ohm resistor. Now, my personal habit is to collapse all the resistors down so that I can get an equivalent resistance for the whole circuit, so I can get I initial. You don't have to start that way. You could just start drawing loops. Okay? So I'm going to start just drawing some loops, because that would probably be the quickest way. So if I have loop 1, I call this I1, it comes into here, okay? At this point, it splits into an I2 and an I3. Okay? Here, at this point, I have I2 coming into here. I'm going to have an I4 here and an I5 here. Now, one of the loops that I can draw would be to start here and just go all the way around the outside. So if I do that, and I start here, I have a plus 24 volts plus a minus I1 times 2 ohms plus a minus I3 times 8 ohms has to add up to be 0. Okay? Then I can have a loop, starts here, and I can have it come around this way. So I have 24 volts plus a minus I1 times 2 ohms plus a minus I2 times 4 ohms plus a minus I4 times 6 ohms equals 0. Okay? Then we could take a loop what kind of loop do I want? Let's see, I have right now 1, 2, 3, 4, I'm gonna have 5 unknowns. I mean 5, yeah, I'm gonna do it the way I like doing it better. I thought I could do it this way and be happy, but I'm not. So first thing I'm gonna do is I'm going to get equivalent resistance. Okay, I'm still gonna leave this I1 coming out of here, I3 there. Now I want to get R equivalent for the whole circuit. Okay, and I'm going to do this fairly quickly. So these two are in parallel with each other. So 6, 1 over. Plus 12, 1 over. Okay, the equivalent here is 4 ohms. 4 plus 4, that's 8 ohms. So right now I've got my battery, a 2 ohm split point here, a 8 ohm, and an 8 ohm. So those two are in parallel with each other. Okay. 8 over times 2. So the equivalent there is 4 ohms. So I'm down to a 2 ohm in series with a 4 ohm. So that's 6. So my equivalent resistance here is 6 ohms, and this is 24 volts. So 24 divided by 6 gives me 4. So I know that I1 is 4 amps. Now, why did I do that? Well, because now if I follow a loop around the outside, okay, loop around the outside, I can go 24 volts plus a minus 4 amps times 2 ohms plus 3 plus a minus I3 times 8 ohms has to be 0. So 24 minus 8, and then I'm going to divide by 8, gives me I3 as 2 amps. So I3 is 2 amps. Okay? Now, if I make a circle like this, so I followed this circle around, okay? Then I am going to have 24 volts plus a minus 4 amps times 2 ohms plus a minus I2 times 4 ohms plus a minus I4 times 6 ohms has to be 0. So 24 minus 8. So I have 16 volts minus I2 4 ohms minus I4 6 ohms has to be 0. So that's one equation with two unknowns. Okay, and then let's see, another loop that I could make would be I can take a loop through here. That's going to add another variable, and then I need a third loop. So I'm going to do that. I'm going to take a loop and go this direction. So I get 24 volts minus 4 amps times 2 ohms minus I2 times 4 ohms minus I5 times 12 ohms has to be 0. So again, I get 16 volts minus I2 4 ohms minus I5 times 12 ohms has to be 0. So now I have two equations and three unknowns, and I can make a third loop here. And if I make a third loop, then I could start here, think about going this way and around this way through the loop. So if I start here, the first component I hit is that 6 ohm resistor. So I have 6 ohms, and I have a plus I4 plus a minus I5 times 12 ohms has to be 0. Okay, so now what I know is that I4 is equal to I5 times 2 ohms. Well, times 2. Okay, so I can look at my equations here. Okay, and I can go 24 volts, well, excuse me, I have 16 volts minus I2 times 4 ohms minus, and I'm going to use I5 times 2 times 6, 12 ohms substitute in there. Okay, wait, okay, I substituted in here. 2, 6 times 2, yeah, that one equals 0. And then I have 16 volts minus I2 times 4 ohms minus 12 ohms, I5 equal, I got the same equation. Drat. I don't need to do that. Okay, what I need to do is use a new loop. Why did I pick one that was so hard? Okay, kind of gingerly erase some things here. Every time you make a loop, you should pick up something new. So I have 3, I have the current I1. I can use a junction rule. I know that I2 equals I4 plus I5. And I know that I1 has to equal I2 plus I3. Well, I know what I1 is and I know what I3 is. So if I1 is equal to 4 amps, that means 4 has to equal I2 plus I3. So I know that I2 is 2 amps. I'm trying to make this harder than it is. So now I know that I2, which is 2 amps, let's plug it in here, okay? Right here, so I have 16 volts minus 2 times 4 ohms minus I4 times 6 ohms has to be 0. So 2 times 4 is 8, 16 minus 8 is 8. So I have 8 volts minus I4 times 6 ohms. So 8 divided by 6 equals 1.33. So I4 is 1.33 amps. And I know that I4 plus I5 has to equal I2. Okay? So 2 minus 1.33 says that I5 is 0.67 amps. I was trying to make the problem harder than it was. I was forgetting to use my junction rules. Okay, use your junction rules and your loop rules, and it's usually a good idea to condense it down to a single resistor to start with so that you have a current to begin with, and it'll make your life easier. I kind of worked myself into a corner and then had to realize it and work myself back out. Okay, but you can do this. I know, it's a little messy. But you guys need to be able to do circuits. Okay, now, okay, when you build circuits, quite often we talk about grounding a circuit. Now, the battery in my camera that I'm using right now is not that grounded, okay? Because it's not connected to a wire that connects it to earth. When we ground a circuit, we take one point in the circuit and we set it as our zero potential point in the circuit because we've connected that to ground. Now, we do this for a couple of reasons. One of the reasons that we set a ground is because oftentimes we will be connecting several circuits up together. Okay? And that gives a common reference point for the components we are hooking together, and it